everything. Hold your clothes. Think about the food you ate today. This building we're walking in, maybe you got on a bicycle there, or we're in a car. Maybe you took a shower with water coming out and faucets and plaster and window glass. And everything you have in your refrigerators, to your cupboards, to your dressers, to your garages if you have one. Everything. Chair you're sitting in comes from the earth. Now you think, no, I just go to a store and buy it. No. The store, yeah, that's where you buy it, but where does the store get it? From a manufacturer who's making money. All right, that's what it's all about. Of course, we need these things. And where does the manufacturer get the raw materials? From the earth. Okay, we either dig it out of the earth, suck it out of the earth, dig for it out of the earth, or grow it out of the earth. All right? Do you want a job? Get into resources. On Thursday, I'm going to start talking about energy. That's a two-part lecture. Today, about minerals. You know, aluminum, chromium, copper, diamonds. You like that? Gold. All of it. Clay. We grow wheat out of clay soil. And we talked about clay. But the thing is that this earth has been here 4.6 billion years to make all this stuff. And it is still making all this stuff. And resources like copper. Well, we need copper. Copper, native copper, all right? Copper throughout this building. It's the only metal that's really suitable to run electricity. Gold would be better, but it's too precious. Not enough of it. We tried aluminum for a while, got a lot of aluminum, but aluminum's got resistance. And what happens when an electric wire gets resistance? It starts slowing the electrons. It gets hot. So the aluminum wiring was causing fires. And so everything that we have in our society comes from the earth. The difference is that our population of this planet has hit 11 billion and it's not slowing down. It's suddenly, like I've said before, in a different context, the earth knows you're here. We're going to run out of stuff. We're running out of stuff. The demand versus supply. Are you in economics? Are you in finance? Are you in business? Are you in manufacturing? Are you in engineering? The earth only has so much of these resources. It's starting to get tight. Right? We're learning new technology. We're learning we need lithium. We need lithium. It makes great batteries. Where would you get lithium? So the earth has 4.6 billion years to make all these resources, but it takes millions, if not hundreds of millions of years for the earth to concentrate, because most rocks don't have anything worthwhile in them. I hold in front of you the 90-million-year-old Cathedral Peak granite from Yosemite, and it's got minerals. Minerals are what rocks are made out of. They are the natural occurring solids of the earth. And most rocks have just a few minerals. There's pink orthoclase feldspar, white plagioclase feldspar, black hornblende, smoky gray quartz. Okay? Those are useful things. I mean, we do take feldspar and make ceramics out of it. Quartz, when it's plentiful, is an amazing mineral. I'll talk more about quartz in just a moment. But to concentrate into ore, here's copper ore, here's fool's gold, pyrite, concentrated. It takes a geologic process, such as hot water, hydrothermal springs that can dissolve and dissolve and dissolve and dissolve mineral as it moves through the rocks, dissolving, getting richer and richer, and then meeting an environment where it's colder, it starts precipitating, concentrating. And then you got ore. That's what ore is, where certain geologic processes take mundane rocks and start concentrating them, where suddenly you've got ore. And I brought all kinds of stuff down here to show you. Galena. We need lead, all right? Lead for batteries, lead for paints. It's a very dangerous metal. You want to kill your roommate? Take a little bit of this galena. It's lead sulfide. Galena looks like lead. Chip a little bit of this off. Your body can't tolerate much lead. Just a few parts per billion. Put it in her coffee, his coffee, tea. A little gritty. Oh, powder it up. And pretty soon the lead gets into your electrons and your brain starts getting warped. You really won't kill them. They'll just go crazy. They might go off and get lost. But we need lead, so there it is. And it's a hydrothermal mineral. You get hot water, precipitates that. We've talked about bauxite, the aluminum ore created by weathering, because weathering dissolves away many of the elements that are here, leaving behind aluminum and some iron. A beer can, we need aluminum. Get in here, gamma phi beta. Sphalerite, oh, we love sphalerite. Take sphalerite, that's zinc ore. That's the best zinc. Zinc's got great kinds of uses. Hi, Dr. Ray. But you can rub it. You can rub it. It smells so. Smell that? Yeah. You're done with me. Yeah. So that's zinc ore, all right, and copper ore. Oh, look at that. Green is malachite. Blue is azurite, for azure, the color of your eyes. Yeah, and some of you might like malachite jewelry. There it is. All right, beautiful minerals concentrated. Minerals that are hard. There's a Mohs scale of hardness from 0 or 1 to 10. Diamond is 10. Corundum's 9. And corundum, as gem qualities, we call rubies. So I'm showing you some rubies here. Got a whole bag of rubies from Sri Lanka. Look at that. All right, they're red. They're not quite gemstones because they're not clear, but they're red rubies. All right, rubies. But there's a lot of uses for the stuff that's hard. All right, we need a lot of oil. We need a lot of water. And you've already learned that most of the water is down inside the earth, groundwater. We drill for it. But if you drill just with steel, you'll melt the drill bit and stud it with hard minerals. Diamonds or rubies. Isn't that amazing? Not gem quality, but it helps us drill down. So these are all things that minerals can be used for. Minerals have different properties. This is an ugly one. This will kill you too. This is mercury ore. Ooh. Called cinnabar. Cinnabar. Blood of the devil. All right? And early prospectors learn how to make mercury from it. All you do is heat it. You heat it up and you drive off the sulfur. That's bad for you. And you're left with liquid mercury. And why do they want that? Because mercury dissolves gold. And when they were discovering gold all over the world, they needed somebody to dissolve it out of the rock. They learned that panning for gold doesn't last very long. Everybody gets that gold too quick. But they learned they could flood crushed gravels in a pit with mercury. It would dissolve the gold out of the rock. And you collect the mercury that has all the gold in it dissolved, and you heat the mercury to a vapor, catch it in a distill, and it drips back down as pure mercury, leaving behind liquid gold. And this was done out in the field, in the foothills of the Sierra Nevadas, gold country. All right, so these different minerals have different uses, and you'll see this in my PowerPoint. Different factors. Quartz. Quartz comes in many different varieties. Down here. Look. Pebbles of milky quartz from a coastal beach. All right. Lovely milky quartz. Here I show you some crystal quartz. Quartz and tourmaline have the special properties that I can take them and squeeze them and electrons start flowing. Or I can put heat on it and electrons starts flowing. It makes a meter go. So I can use this to sense heat. I can use this to sense pressure. This is how we determine the blasting pressure of an atomic bomb. This is how we detect the passings of a submarine when this propeller thump, 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 thump in water causing pressure. I put this, and I can pick up the center of a submarine. All right? Crazy. That's quartz. It has the ability to flow electrons. This is the original crystal quartz. Look at that. Polished brown, perfect sphere. Well, I can take this and put it up to you and read your mind. Ooh, those thoughts you're having. Yes, there they are. I know your history. I know what you did last night. Oh, it's all in here. Beautiful. Iron ore. Iron ore comes in two different varieties, hematite and magnetite. Magnetite because, look, it's magnetic. Magnets all over it. Magnetic. That is the most precious iron ore in the world because you can crush up a mountain that has some magnetite in it and then go up with a magnet, pull it all out. Okay? That's how we do it. Hematite and magnetite are magnetic. Magnetic, right? Wow. All right? So different minerals have different abilities, different properties. Some are clear. I see you. Some are colored, like sulfur. All right? Did you brush your teeth this morning? You like our toothpaste to have what in it? Fluoride. Well, where do you get the fluoride? Here it is, fluoride. Okay, pretty good stuff, right? Okay, so that's fluoride, all with different properties. Some minerals have iridescence. Look at the play on colors. You see that? So come down here after class. Some minerals like asbestos are fibrous. Ooh, have I done that for you? It's stuck, Mama. All right, so minerals vary in their properties and what they use for, and some of those properties are what we can do. So we'll go through now and take a look at some of these different minerals and what they're all about. So it is a naturally occurring solid. There used to be a rule that it had to be inorganic, but we don't buy that anymore. Because a lot of organisms, like mother of pearl, made by an oyster, certainly causes that to grow. But they have a definite atomic arrangement. All right, so that's what a mineral is. They have different properties. Oh, look at that. Tourmaline growing on quartz. Both of them, pyroelectric and piezoelectric, flow of electrons, the heat and fire. Lovely, lovely stuff. They have a certain hardness, tenacity. That means can they bend? Some have striations. They have a form of we call habit, how they grow. Their density, their cleavage. Some of them doubly refract. These are also, you go into a mineral, you take a course right in this building called mineralogy, and you learn how to identify minerals by using these kinds of physical properties that are there. Some of them you can taste, some of them you can smell, all right? So they're all there. Some have particular color. Some will fluoresce. If you put ultraviolet light on them, they'll come back with you with great different kinds of light itself, all right? How light interacts with the mineral. Some of it, they have luster, they have certain reflections, they have a streak that is the color of the powder. Some of them are transparent. So all of these are part of that scale. There's Mohs hardness scale. Talc, talcum powder, put some talc on your baby's butt, right? It's a mineral. Talc is from talcum powder from talc, okay? Gypsum is number 2. Gypsum is a very soft mineral. Your fingernails got a 2.5, so I ought to be able to scratch gypsum with a fingernail, okay? And I can't. There it is, brand new scratch, okay? I won't scratch my bigger ones up here, but these are all gypsum. Gypsum's a wonderful mineral. Look at that wall. Made out of plaster. I'm sorry, I walked right through. Made out of plaster. Where from? Gypsum. Okay? Made from gypsum. All right? Gypsum is a mineral concentrated by the evaporation of oceans and seas. So in that evaporation is a geologic process that concentrates. All right? So there it is. All right? We need a lot of plaster. All right? We're still building all the time, putting up new buildings, and they need new walls. Okay, so that's the hardness scale. Cleavage. You thought you knew what cleavage was. Cleavage is how a mineral breaks. Now, some minerals don't break in any particular fashion. They have a irregular fracture, and so that's characteristic. Other minerals break into planes. Where's my... Oh, look at this. So lovely. Muscovite and biotite micas break into planes. And here I'm going to peel, ripping atoms apart that are holding the layers together. All right? Mica has a lot of uses. Mica, it's an insulator. Electrons can't flow through it. And so for years we used this around lanterns. All right? It was the window around the early Coleman propane lantern for camping. Didn't have a glass mantle, I had a mica mantle. I have one with my grandfather's in Illinois. All right, mica. Used as an insulation for electricity, mica. It's got cleavage, don't you see? Cleavage. Camlin, come up here for a moment, would you? I want you to demonstrate. Can you swing a hammer? Come around over here. Now, you see, calcite, the mineral calcite, calcium carbonate, the mineral of limestone and marble, it's got not just one plane, but two, but three. Makes it a box, pushed over box. And so Camlin, going to kick ass up here, and Camlin, I want you to take that right there, and I want you to smash it. Yeah, you know, about like this. All right? Wow! What's the coolest thing you ever saw? You do kick ass. Look at that. Oh, wow. And so you... Look at that. Come down after class. Here's another one. Somebody can break this one as well. So I got them for you. Calcite. And it's breaking into, it's cleaving, it's breaking, all right? Mommy, I learned what cleavage really is. I'm not done with you. All right. Other minerals, they splinter off like asbestos, or they have conchoidal fracture. Arrowheads have conchoidal fracture. Conchoidal means rounded. Gives us the shapes. Others have irregular. Look at that arrowhead. So all about how the mineral breaks. They don't all break up into planes. That's part of that. All right. Pyro and piezoelectricity I've been mentioning. They have so many different uses. Timing devices. Yeah. I said if you put pressure on quartz, it'll cause electrons to flow. Reverse that. Put electrons on quartz. It'll pressure itself. It'll start beating like your heart. Bump, 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 bump. So precise. You can make a clock work. Crystal watches. What's the crystal? Quartz. If you have a battery in there, pretty soon the second hand is going around. It's all about minerals. All these things, all these gifts. All right? Amazing. So, minerals. Here we're looking at the Cathedral Peak granite. There's a beautiful orthoclase feldspar, white plagioclase, hornblende. But these things make up rocks. That's what minerals are, naturally occurring solid. There's a lot of stuff out there that aren't minerals. And the health industry confuses this. Sodium is not a mineral. Write it down. Sodium occurs as a dissolved ion in seawater, but not as a naturally occurring solid. Potassium is not a mineral. I don't care what the health industry says. Where do we find potassium? Bless you. In bananas, you bet, as a dissolved ion in bananas. Now we can take that seawater and smash up that banana and evaporate it, and it will have to grab on to some chlorine or some other anion to make a mineral, like sodium chloride or potassium chloride. Lead is not a mineral. Aluminum is not a mineral. Aluminum occurs as a hydroxide in bauxite. Okay, so a lot of the periodic table are not minerals. Gold is, silver is, copper is, sulfur is, carbon is in the form of diamond or graphite, and that's pretty much about it. Okay, I'm going to have another Earl. Can you and Emily come up here for a moment? Are one of you any good with a big lighter? Just with both this. Come up here. Yeah. Look at that. We love fire. This is a highly dangerous spectacle that we're about to do. Emily, I want you to light this stuff. Can you run a big lighter? And Earl, you're a good-looking guy. It's been nice knowing you. I want you to stand here. Earl does a very dangerous job. You stand here. All right. I want you to. This is magnesium metal. All right. The ribbon of it, not a mineral. All right. We can buy lead, copper, aluminum. Copper is a mineral, but these are made synthetically. I could have brought potassium and sodium in here, and they would have exploded. This is going to explode too, I think. We get it going. It's not a mineral. It's very unstable, and if you add some flame to it, it will leak into an exothermic reaction to make a mineral called brucite, magnesium hydroxide, getting oxygen and hydrogen out of the air. Earl, this is your safety net. You hold that, and don't drop it in the water. And then once it lights, don't look at it. Don't look at it. Or do. And then after it burns for a while, you must get it in that water and not on the rug, or we could all have to evacuate. Crazy. Okay, light them up. Light them up, yeah. There you go. Hold it steady. Right there. Right the hot part, right? Amazing. Exothermic reaction. Amazing. Drop it in the water. Wow. Earl and Emily. Now, sometimes I do all these funny, odd demonstrations, break a rock, scratch this. I don't know what he was doing, but it was kind of funny at the time. We were demonstrating to you that magnesium, like most of the periodic table, is not a mineral. We can make it synthetically. It's not natural. And give it some energy, and it will leak, Katerina, to making a mineral by a reaction. And most reactions give off heat. They're called exothermic. Burning a log is an exothermic reaction. Okay? Exo versus, what's the opposite? Oh, there you go. All right. So, a bit about the properties of minerals. Some of those properties are useful, and how we know what minerals are. Mostly minerals that are very abundant are not all that useful. So the ones we really want have to be concentrated somewhere. They need some way to concentrate. Copper, only 0.006% of the earth. So it's got to be concentrated 100 times. We want mercury for our thermometers, a lot of other reasons. All right? But in a natural rock, an average rock will have mercury, but only about 80 parts per billion. So it's got to be concentrated by the Earth's environment, a geologic process like hot waters we call hydrothermal, that will dissolve it and concentrate it 25,000 times into cinnabar. Whoa, cinnabar. So let's talk about something. Hydrothermal, that's hot water. All sulfide minerals like pyrite, galena are hydrothermal, gold, silver, quartz veins. You wouldn't want to drink a hydrothermal glass of water. You wouldn't want to drink a hot spring. You told me you smelled the sulfur there. It's so hot, heated water, dishwater, heats. Dishwater dissolves, all right? Moving through the rocks, dissolves, dissolves. It gets harder and harder and harder way up there. Harder. And then, like I told you, it reaches a cold environment and then it starts precipitating, okay? A lot of this, as we'll see in a minute, are at we call smokers at mid-ocean ridges. These are underwater hot springs. It turns out most of the world's gold is formed on mid-ocean ridges. You now know what mid-ocean ridges are from the plate tectonics. Well, down in that hydrothermal environment of the ocean ridges, where you have upwelling convection cells, you've also got convection cells of hydrothermal fluids. Dissolving, dissolving, and hitting, coming out in the cold water and precipitating. Igneous minerals include diamond. Oh yeah, and chromite for chrome. Sedimentary minerals, placer gold, quartz sand, limestone. We need limestone. This building is made out of limestone. Precipitated by fossils. I told you it's a fossil hash. Oh, hey, get in here. Hi. Gypsum, borax are all sedimentary minerals. Some occur by evaporation. That's still sedimentary. Metamorphic minerals include minerals like talcum powder, talc, made by pressure and temperature, asbestos, garnet, ruby. Oh, good. Others, weathering. You know about weathering, making bauxite and clay. We'll learn, we know you do know about uranium. We've talked about groundwater, haven't we? We've done groundwater. Yeah. So that makes uranium. In the deep oceans, oil and natural gas is made from living, mostly one cell, living and dying and sinking down to the mud. We'll talk about deep marine oil and gas and coal on Thursday. But the accumulation is slow. So when you come in and dig out a whole mountain of coal that took millions of years to accumulate, we have gone through half our oil. We've gone through almost half of our natural gas. You're going to see the end of oil. Yeah, me, yeah. But it's all part of the rock cycle. The rock cycle involves, heating of the earth, making magma, igneous rocks. I'm melting. And those igneous rocks can, in place, crystallize at depth, or they could go up and make volcanoes. But those rocks weather, get transported by rivers and wind, become sedimentary rocks. I'm sedentary. The sedimentary rocks get buried, pressure, hey, get in here, changes the sedimentary rocks back to metamorphic rocks, and then those start heating again. It's all part of the rock cycle. And every part of the rock cycle forms different kinds of ores. Some that are rich in metals, some that are rich in non-metals. Igneous rocks, look at Mount St. Helens. Oh boy, minerals, beautiful crystal hornblende and a feldspar. I like that. And with my dog nugget for scale,